Double integrals over general regions. We're going to talk about switching the order of integration in this video. We're going to go through two fairly straightforward examples. First of all, we have a double integral 5xy squared dy dx. X goes from 0 to 1, y goes from 0 to 2. It's over a rectangular region, and very easy to switch the order of integration in this case. All we do is just switch the limits. And there's really nothing more to it than that. You have to switch dy dx to dx dy. 5xy squared is the same. You can switch it to 5y squared x if you really want. If you want to reverse the alphabetical order, there's no point to that. That's easy. Now in this case, we don't have a rectangular region. We have 0 to 3, 0 to 4x. And we saw before that these were x coordinates and these were y functions. And if we want to switch the order of integration, there's two things we have to do. X squared y, we have to switch this to dx dy. And then we need to take these limits and draw the picture. If on a problem set, if you switch this, if there's no picture, 0 credit. Okay. Got to have the picture, and you go from the picture to here. It's the only way to do it. So, well, guess what? Y equals 4x, this straight line, and y equals 0, this straight line, and x is going from 0 to 3, so this tells us what section of this triangle we have. If x went from 0 to 5, we go further out. If x went from 2 to 3, guess what? We have this thin slice of the triangle, and it wouldn't be quite as simple. So now we can switch the order of integration. Y goes from, y's constant, that goes first. Y goes from 0 to 12. And then x goes from here to here. X over here is y over 4, and x over here is 3. So we have to go from y over 4 to 3. Okay, and you can go ahead and integrate that. I'm not going to bother you with the details. That's pretty simple. Let's go through one more example. This one's a little more challenging. It's similar in nature, except for we're only going to let x go from 2 to 3. So we can change our picture. And you can graph y equals 0 first of all, and that's pretty easy. Easy peasy, y equals 0. And then you can graph y equals 4x. But the problem is x only goes from 2 to 3, so you can sketch x equals 2, x equals 3. Let's move this y equals 0 up here. Now, if we want to set this up as a double integral, 5xy dx dy, the problem is y goes from here to here. This is still 312. This point here is going to be 2, 8. And the problem is if y goes from here to here, x has to go from left to right. Well, the problem is you can break this up into two different regions. Here x goes from vertical line to vertical line. Here x goes from slanted line to vertical line. So we'll call this region 1 and region 2. You can set them up, doesn't matter which way you do it. I'll do region 2 first. It's a rectangular region. You can set up y first. Y is going to go from 0 to 8. Now then x is going to go from 2 to 3. Five xy dy dx. Okay. Now this is going to be region 1, that upper triangular region. X first. Oh, I switched those around. Sorry about that. Dx dy. You could do it the other way, but the whole point here was to switch the order, so we better do dx dy, better follow directions. Y is going to go from bottom to top. Y starts at 8, ends at 12. Then you have to solve for x here. X here is y over 4. Now then x here is just x equals 3, the constant 3. So there you have it. It becomes a little more complicated. Easier to do this way than this, obviously. So you can evaluate this, get an answer. If you're really curious, you can even go online, find an online multiple integration utility, Wolfram Widgets or something like that. You can evaluate that, evaluate that, evaluate that. That plus that should equal that. So if you have an extra $150 to spend, you can buy a TI Inspire. It's a nice calculator. It will do multiple integrations. It gives you a nice graphical user interface. You can bring up a multiple integral actually and just fill in all the limits, hit the button, and it gives you an answer. Usually gives you an exact answer with radicals and sines and cosines or whatever. Not a bad idea to learn how to use that actually. It's a pretty useful tool. So, okay, that's all for this video.